Hi once again. Dears, in the last video you have studied double angle identities. You have studied double angle identities. Double angle identities. Tell me now how to get these identities by using some identities which you studied in 6.2. By using this some identities, you can get double angle identities. Here, double angle identities are found for sine 2 alpha, cosine 2 alpha and tangent 2 alpha. But for the cosine 2 alpha, we know we have three formulas. 1, 2, 3. This formula we can get it from some identity, but there are two more formulas which we got from the Pythagorean identities. We know it. Just watch that video, the first one, how to get the double angle identities. Now, the next one is power reducing identities. Power, we are reducing, power reducing. How to get the power reducing identities? Yes, power reducing identities we can get from double angle identities. By using double angle identity, we can get the power reducing identities from double angle identities. Now, power, we are reducing the power. So look at these three identities. Where do you have power? In sine 2 alpha, do you have power? No. In cosine 2 alpha, yes, we have power. In tangent 2 alpha, no, we don't have power. So in this case, we are considering only cosine 2 alpha. We are taking cosine 2 alpha. Cosine 2 alpha is equal to cosine square alpha minus sine square alpha is equal to 1 minus 2 sine square alpha is equal to 2 cosine square alpha minus 1. Now we want the power reducing identities. So power, for the sine we have power, for the cosine also cosine square. Power reducing identities. Here you can see double angle doubled, 2 alpha. Here power. Now sine square alpha, cosine square alpha and tangent square alpha. We can see the formulas for this. Now for the sine square alpha, we are taking cosine 2 alpha 1 minus sine square alpha. Cosine 2 alpha is equal to 1 minus 2 sine square alpha. What we want? We want sine square alpha. So first we take 1 to other side. Cosine 2 alpha minus 1 is equal to minus 2 sine square alpha. Is it? Now what we do next? Next we want sine square alpha. Yes, we divide minus 2. Here also we divide minus 2. Okay. Now what happens? Minus 2 can be cancelled. So what we get? Sine square alpha is equal to cosine 2 alpha minus 1 over minus 2. So now what we do? We multiply this minus 2 here. Minus cosine 2 alpha minus 1 over 2. So it will be 1, because minus into minus plus 1, minus into cosine 2 alpha minus cosine 2 alpha over 2. So we got the formula for the sine square alpha for the sine square alpha, that is 1 minus cosine 2 alpha over 2. Next we want the formula for the cosine square alpha. For that, we are considering cosine 2 alpha and 2 cosine square alpha minus 1. So what we are taking, this is for the first formula. For the second formula, we are taking cosine 2 alpha is equal to, it is equal to what? 2 cosine square alpha minus 1. 2 cosine square alpha minus 1. What we want? Yes, we want cosine square alpha. So first we take 1 to other side. So it will be cosine 2 alpha plus 1 is equal to 2 cosine square alpha. Now what we want? We want cosine square alpha. So we divide by 2. Here also we divide by 2. So 2 cancel. So we got cosine square alpha is equal to 1 plus cosine 2 alpha over 2. So now we got the formula for cosine square alpha, that is 1 plus cosine 2 alpha over 2. Now we want the formula for the tangent square alpha. We know what is tan alpha. Tangent alpha is sine alpha over cosine alpha. Now tangent square alpha is sine square alpha over cosine square alpha. We have sine square alpha, that is equal to 1 minus cosine 2 alpha over 2 over, what is cosine square alpha? 1 plus cosine 2 alpha over 2. Now 2 cancel. So what left? 1 minus cosine 2 alpha over 1 plus cosine 2 alpha. So the formula is 1 minus cosine 2 alpha over 1 plus cosine 2 alpha. So we got the formula for the power reducing identity is, that is this, sine square alpha 1 minus cosine 2 alpha over 2, 1 minus cosine square alpha over 2. Cosine square alpha is 1 plus cosine 2 alpha over 2. Tangent square alpha is 1 minus cosine 2 alpha over 1 plus cosine 2 alpha. Okay, this is for the first formula, this is for the second one, this is for the third one, the solution. So how did you get the power reducing identities? From the double angle identity, from cosine 2 alpha. This identity we got power reducing identity. Next one, why we need the power reducing identities? To find the half angle identities. So